Hi everyone. In this video, we're going to talk about addition reactions of alkenes. So actually, alkenes has several reactions such as addition reactions, polymerization reactions, and oxidation reactions. And we will start from addition reaction. Addition reactions of alkenes can be occur if alkene react with hydrogen. This is called as hydrogenation, or react with water. Yeah, this is called as hydration, also called as hydration, or called with bromine or any other halogens, yeah, called as halogenation. And if it is Br2, it is specific known as bromination, and also use HBr in aqueous solutions known as hydrohalogenation. We will start one by one, start from hydrogenation. Requirement for addition of hydrogen to alkene is nickel catalyst and high temperature, which is 150 degrees Celsius. Okay, this is known as reduction as well, since alkene will change to alkene. Okay, I'd like you to start make notes, yeah, regarding the types of reactions. Okay, you already know that alkene has combustion and free radical substitution. Now we are here, alkene. So there are several reactions actually of alkene. Start from one, yeah, hydrogenation. Please don't forget, when you make the summary or make notes, yeah, it is very important for you to state the catalyst, yeah, that means the condition and the conditions stated for these reactions to occur, such as catalyst or temperature. Okay, for hydrogenations, nickel and 150 degrees Celsius. And what's the product formed? Yeah, after these reactions occur, yeah, it is changed alkene to alkene. Hydrogenation used in manufacture of margarine. You know that to convert the saturated hydrocarbons to unsaturated one, yeah, to form a solid margarine from the vegetable oil. Yeah, so that's why the hydrogenation process will change the liquid forms of oil to the solid form of fat. Yeah, since hydrogenations make and change the unsaturated to saturated. Okay, next reaction, this is number 2, is hydrogenation. Sorry, not hydrogenation again, but hydration. This is additions of water. This is very important for you to understand that the water used here is not in liquid form, but in steam form, yeah, or in gaseous state. Okay, so H2O in gaseous state, and the catalyst used is concentrated phosphoric acid, okay, or sulfuric acid. Temperature 330, pressure 6 megapascal. This changes alkene into alcohol. Yeah, addition alkene to steam. Okay, you can see here that first alkene react with sulfuric acid, the catalyst, to form alkyl hydrogen sulfate, and then next water can be added here, and then SO3 H will be released, and OH will be replaced here to form alcohol. Okay, this is how the hydration occur. So hydrogenation, nickel for 150 degree, hydration, concentrated sulfuric acid or phosphoric acid, 330, 6 megapascal, yeah. That's the hydration. Don't forget, water in vapor state, yeah, H2O gas. Okay, now let's answer this question. Okay, the answer is addition. Okay, since this is alkene, add with H2O to form ethanol. This is addition reaction. You know that this is an electrophilic addition, yeah? Okay, the third reaction of alkene is addition of halogens, X2. In case of bromine, yeah, it has a color, a brownish color, yeah, and it will change to colorless if the addition reactions occur. And no need to use a catalyst or heat, yeah, since this is quite a reactive reaction. So just RTP condition, okay, room temperature and pressure. Okay, so these reactions can be used to test for unsaturation if the decolorization occur, indicate the presence of alkene group. Okay, try this. Give the name and structure of the products, yeah, of the following reactions if alkene react with H2 over Ni catalyst. Okay, let's discuss with hydrogen, CCCC. Okay, so double bond will be disappear. The name is butane, right? Concentrate H2S4. That means you add water. This form alcohol. So the name is butane to all. Yeah. How about this? Okay, with SBR, CCCC. This is Br here. Okay, 2 bromo butane. Okay, that's about reactions of alkene. Next. Okay, what's the answer? Oh, sorry. Bromine reacts with ethene in the dark. Which description of the organic intermediate in this reaction is correct? Okay, okay, ethene react with bromine. Okay, you already learned about this, right? The intermediate is carbocation. Yeah, it is an electrophile. Next. Okay, let's answer this. Bromine and propene undergo addition reaction. This is propene. Okay, with bromine. Okay, to form intermediate. Sorry, propene. 3 cis only. Okay, so this is the product. Which is the property of the product? It exists in cis trans isomer. Wrong, right? Since there is no double bond, there is no ring, so we'll not have cis trans isomer. It is more volatile than propene. Is it? No, that's wrong. Why? Because MR of this molecule is higher compared than propene, right? So it is should be less volatile than propene, since the van der Waals forces should be greater, yeah, compared than in propene. It possesses a chiral. Okay, let's see if we have chiral center here. Okay, let's compare it with hydrogen. Okay, do we have this, right? So this is correct. It possesses hydrogen bonds. Not correct, yeah, since this is they have no FO or N or any positive hydrogen, so there will be no hydrogen bonds. Okay, the fourth addition reactions of alkene is hydrohalogenation or addition of HX. Okay, you can see that the monohalogen alkene will be produced here. One H goes to one C double bond, and the other Cl will goes to the another C double bond. So all the hydrogen halides are able to react in this way, but reactivity in order Hi is more, yeah, compared than HBr, HCl due to the decreasing strength of hydrogen halide. So if you use Hi, the rate of reactions will be faster, yeah. So reacts most readily with Hi. There is a problem here in additions of HX because of the product will be differ if you add in symmetrical alkene and if you add in the unsymmetrical alkene. Symmetrical alkene is like ethene here. Okay, look here, this is symmetrical. If you add with ACl, for example, no matter H goes to the DC or DC, right? Okay, the product always chloroethene. Yeah, it could be this or it could be this. This is called as symmetrical alkene. Yeah. Okay, this is the product if a hydrogen goes to the Cl. Hydrogen goes here. This is hydrogen. So Cl will goes to the DC. But in the second case, hydrogen goes to this C. So Cl will goes to this C. 1 and 2 same. Yeah. Ethyl chloride or chloroethene. Yeah, will be produced. This is symmetrical alkene. But how if we have unsymmetrical alkenes such as propene? If you add with ACl, okay, please remember that there are two possibilities of hydrogen. Let's say hydrogen goes to the C. Okay, I will complete with X first. So what the result? CH. Okay, this is the incoming H, yeah. I will use the different color. Look here, H, CH, CS3, and this is positive, right? So later on Cl will goes here, will attack here. So Cl here. Okay, this is the first product that can be produced, yeah, if you add propene to HCl. What's the second product? The second product occurs if H goes to the C. Okay, then it will produce, okay, this H, right? And then Cl will goes here. Are they the same compounds or different? Okay, let's try to give names. Okay, this is 2-chloropropane, while this is 1-chloropropane. So they differ. So additions of HCl in unsymmetrical alkene will produce two products. Yeah, which one will become a major product and the other will become a minor product. Now we want to know which one is the major, which one is the minor product. How to decide? Okay, this is due to the stabilization of carbocation that will be formed. Okay, now let's see. I will erase here. Okay, please listen carefully since this is quite difficult. Yeah. Okay, the rules to understand about this called as Markovnikov Rule. Okay. In the addition of HX to an alkene, the acid hydrogen becomes attached to the carbon with fewer alkyl substituent, and the halide becomes attached to the carbon with more alkyl substituent. Okay, to understand about these rules, okay, let's see about the intermediate that form during this electrophilic addition mechanism. Okay, here CHH CHCS3, first double bond attack the hydrogen chloride, right? Hydrogen chloride is a polar compound, yeah. So Cl already negative partial charge and it's already positive partial charge due to this is polar. So the polarity is not because of polarized by the double bond, yeah. Not because of polarized of the double bond, unlike bromine, which is neutral. ACl is a polar, so direct react by the double bond, yeah, attacked by the double bond to H, and then the heterolytic fission occur to form the Cl anion. Okay, what's the product of this intermediate? Okay, let's say I like to form the 2-chloropropane first. Okay, okay, you can see as well from the Markovnikov rule that hydrogen, yeah, from XX will attach to the carbon with fewer alkyl substituent. Okay, which one C that has the fewer alkyl substituent? This is the first C. This is the second C. Which the first C or the second C that has fewer alkyl substituent? It is the first C, right? The first C only attaches to 2H. There are 2H. While the second C attaches to 1H and 1R. So the fewer alkyl substituent is the first C. Okay, so hydrogen will goes to the first C. Okay, hydrogen will goes to the first C here, hydrogen. So the second C will have positive partial charge or positive charge. Carbocation will here. Okay, and then next the Cl negative will attack this C to form the product. Yeah, this is 2-chloropropene. Okay, why Markovnikov rule state that each will attach to the carbon with fewer alkyl substituent? Why? Why? Okay, don't forget about the stability of a carbocation. You can see if hydrogen from HX goes to the carbon with fewer R group, it raises to the formations of secondary carbocation. Right? Secondary carbocation, this is R, this is R. So this is more stable, okay? More stable, so that's why this is the major product. 2-chloropropane will be the major product. Let's say, let's see if we have another opportunities for how the hydrogen bonded to the C. Okay, the another possibility, hydrogen will attach to the second C, right? To the second C. Okay, where I should draw? Wait, I need space. Okay, let's see here. Okay, look here. Okay, the another possibility of how hydrogen attaches to the C double bond is to the second C. Okay, this is hydrogen from the initial molecule, and this is hydrogen from HX, yeah. Okay, you can see that this is positive now. Okay, you can see that this is a primary carbocation. And you know that the stability of primary is less compared than secondary since it has only one R group that can help to stabilize the charge, yeah. So this is least stable and will lead to the formations of minor product. Which one is the minor product? Is when the Cl this carbon and form one chloropropane. So one chloropropane is the minor product. So this is makes sense, yeah, of the Markovnikov statement that acid hydrogen, the hydrogen from SX will attach to the carbon with fewer alkyl. Yeah, since it leads to the formations of the more stable carbocation. Yeah, so this is preferable. So this will be the major product. Okay, understand? Hydrogen goes to the more fewer alkyl group. Yeah, to the carbon with fewer alkyl group. Or sometimes people try to memorize that hydrogen will goes to the C double bond will that have more hydrogens. Hydrogen goes to the more hydrogens. Okay, you can see that among between carbon number 1 and carbon number 2, the more carbon that has the more hydrogen, I mean, is the first carbon. So hydrogen from SX goes to the C double bond with more H to more H. So it is easier to memorize. Okay, so if it attack the first carbon, then the positive charge will be at the second carbon, lead to the formations of secondary carbocation. Okay, let's read this practice question first. Okay, let's draw the methylpropene. Methylpropene, CH3, 2 times C, so it will be like this. Okay, and then this is CH2. Yeah, methylpropene. Okay, with hydrogen bromide. So this is hydrogen bromide. Don't forget to give positive and negative partial charge here. Draw the arrow from electron density double bond. Heterolytic fission, don't forget. We already make this several times. I hope you already remember about this mechanism. Okay, hydrogen goes to the C, that more hydrogen. That means to the CH2, yeah, to the first carbon. This leads to the formation of secondary carbocation at tertiary, yeah. This is tertiary, very, very, very stable. So that's why later on Br negative will attack this side, yeah, to form. Okay, to form this. Yeah, 2 bromo, 2 methylpropane. Yeah. Okay, include the structure of the intermediate and all necessary charges, dipoles, lone pairs, and curly arrows. Okay, the structure, okay, we already make this, okay, although it is not required. Okay, 1 bromo is formed in small quantities, yeah. because if hydrogen goes to the second C, it led to the formations of primary carbocation, and it is very not stable compared to the tertiary one. Okay, actually there are 4 points for this. Okay, let's see how to get a point. First point is for if we draw the curly arrow from the C double bond to H. Okay, this is the first point. If you draw this arrow, correct orientation, you get 1 point. The second point is for the correct dipole, positive, negative here, the correct dipole, and arrow from bond to HBr, from bond of HBr to Br. So that means this is this bond, okay? This arrow, I mean. So this is the second point, the correct dipole and the heterolytic arrow, yeah, of HBr. The third point is for the correct structure of intermediate, the tertiary carbocation. So the structure, okay? If you draw the structure correctly, you will get 1 point. Yeah, that means you already understand that hydrogen will goes to the first C. Yeah, not the second C. Okay, the last point is for the arrow again from lone pair. So you should draw the lone pair here. Yeah, lone pair of Br minus to C positive. Okay, this. Okay, the last point. Okay, 1, 2, 3, 4. So there are 4 points for this type of question. Okay, don't miss any points. Yeah, because sayang. Yeah. Okay. Oh, I think we already did this, right? Okay. Explain why 2-bromo to methylpropane is the major product of this reaction. Explain why. 2 points for this. Okay, this is how you answer this question. Because it formed through tertiary carbocation, right? It's very stable due to positive inductive effect of 3 R groups. Okay, look how to get these 2 points. Okay, this is because you state about tertiary carbocation stable, yeah. This is 1 point. Then you explain why it is stable. Okay, because of the positive inductive effect from R group, yeah, from many R groups, yeah, positive inductive effect for this. This is 1 more point. Okay, so I already taught you to get the perfect point, yeah. So this is how to answer this question. Next question, which reaction is not an electrophilic addition? The answer is D. Why? You know that alkene can react with XX, yeah, such as this, Br2, X2, H2O, concentrated H2SO4, electrophilic addition. But this is not electrophilic addition, CS3, COH with ACN. Okay, you know that this is nucleophile, right? Not electrophile. So this is nucleophilic addition. While electrophilic addition, the double bond should attack the positive atom, yeah. Electrophile electrophile. This is electrophile. Addition. Okay. Next question. Limonene is found in lemon and orange oils. What will be the major product when limonene is reacted with an excess of dry hydrogen chloride? Okay, please pause this video. Okay, let's discuss now. Yeah, this react with hydrogen chloride. And there are two double bonds here. So there are two possibilities to attack this H, right? Okay, do you think this is a symmetrical or unsymmetrical alkene? Unsymmetrical, right? So the product or the intermediate will, according to the Markovnikov rule. Okay, Markovnikov rule states that hydrogen from HX will go to the C that has more H, right? Okay, with C that has more H. Okay, let me zoom this for you, yeah. Zoom this for you first. Okay, with carbon that has more H. Okay, look here. This carbon has 1, 2, 3. So this is 1 H, right? For this 1, 2, 3, 4, this is 0 H. So if this attack HCl, the H from HCl will go to the C that have more H. Okay, so this will lead to the formation of, this is H, and this is positive charge here. Okay, so that means before we have 1 H, after the H from HCl added to this, so there will be 2 H right here. Okay, but no need to show the hydrogen. Okay, just like this. How about the below part? Yeah, this. Okay, how many H here? Okay, there are 2 H, right? And this 1, 2, 3, 4, so 0 H. So hydrogen from hydrogen chloride also goes to the more H. Yeah, will goes here. So the positive charge will be here. Okay, you know that this is electrolytic, so Cl minus will be formed. Then the Cl, electron of Cl will attack this region, and this will attack this region as well. Okay, so what's the product here? Would be Cl here and Cl here, right? So you just compare with the option. Which product is it? It is C, yeah? It is C. Okay, understand? Why C? Why not A, for example? Since the question is reacted with an excess of dry hydrogen chloride. If not in excess, maybe only one double bond that will added by HCl. But since the question is already state that this is in excess hydrogen chloride, so all double bonds will be undergo addition reactions with hydrogen chloride. That's why C.